So in the last session, we were doing inference and predicate logic, and we had just seen how forward chaining actually works. So when we use forward chaining, there's a lot of inefficiency there, and the source of the inefficiency is because in every iteration, you are going to check, every rule to see what are the facts that match the left side, okay, and then we are going to infer the right side. But this may take a lot of time because you need to use what is called the pattern matching, and this pattern matching actually is what takes time. So, what are the ways in which we can speed this up? That's what we are going to see. So, the first one is that the matching the rules against known facts. Okay, so in other words, for example, if you have something like missile X implies weapon X, we need to take missile X and we need to see what are the facts in your knowledge base which will actually match with this missile, okay, and you need to do the substitution for X depending on those facts which you have. So what happens is if you have a lot of facts with missiles in it, you'll find that it takes a long time to do that, okay. But suppose you have something like this, okay, and you know that there are many objects owned by Mono, but very few missiles. So suppose you start with the missiles, okay, so you start with missiles, missile say M1, missile M2, etc. You may find that depending on the order in which you do this, the time that you require may change, okay, and we may be only interested in say one missile or two missiles and not all the missiles, etc. So it makes it much faster to take care of the missiles and then go to matching owns, right? So this is what is called the conjunct ordering problem. So whether you do A and B first or you do B and then you do A, it doesn't make any difference. So you find an ordering of these. So once you find an ordering, you can do according to the ordering. So once you do that, you can minimize the speed or increase the speed and minimize the cost. So this is called the minimum remaining value heuristic, okay, which suggests ordering the conjuncts to look for missiles if fewer missiles than objects are owned by no, right? So that is one method of speeding it up. Second one is what is called incremental forward chaining. So every time you try to find a rule and match with the facts which are there, you should say that at least one of the facts are what was inferred in the previous iteration. Because if it wasn't inferred in the previous iteration, then it would have done this in the previous iteration itself or in some previous iteration, right? So you can see that at least one of the new facts inferred in the previous iteration is there in that rule. So if it isn't there, then you needn't worry about that because the fact which it's inferring is already been inferred. Okay, so that is what is known as your incremental forward chaining. And third one is to remove irrelevant facts. Okay, so what you do is depending on what is it that you are trying to prove, there may be many facts or many rules which are sort of irrelevant to what you are doing. Okay, so you rewrite your rule set once you know what you are trying to prove. You rewrite your rule set using information from the goal so that only relevant variable bindings are used. Okay, and they call that as the magic set. Okay, for example, if the goal is criminal West, okay, and so the rule which implies criminal X is an important rule. So you put magic X at the beginning of this, okay. So once you do that, then it gives more importance to this rule as compared to the other rules, because we are trying to prove criminal West. We can also give importance to the facts in the database which has West in it. Okay, magic West is also added, because we are only looking to see whether Colonel West is a criminal. Okay. So these type of things can be added to it to speed it up in some way. Okay. Okay, so that is the forward chaining. So we have seen the forward chaining up to now. Now let us look at the backward chaining. Okay. So in the backward chaining, you go backward from the goal. Okay. So when you are trying to prove a goal, you see, find that goal on the right side of a rule. So when you find that goal on the right side of the rule, you try to see whether the premises which are there on the left side of the rule are true. Okay, so that's how you can prove. Okay, if the knowledge base contains a clause of the form LHS implies goal, okay, and LHS is a list of conjuncts. Okay, for example, King John and whatever earlier we saw, and whatever, or something like American X and weapon Y, etc. So your LHS has a number of conjuncts in it, right? So, and the goal is on the right side. So you take this list of conjuncts and you try to prove each of them separately, okay, by looking at the facts which are there in your knowledge base. And of course substitution will have to be carried out appropriately as you go along. Okay, so this is your backward chaining. Okay, so for each rule, okay, you check whether your RHS is the goal that you are looking for or contains the goal which you are looking for. Then you take the LHS, okay, and you check whether every term in LHS is true or not. Okay, so that is how this actually works. Okay, so this is your proof tree. Okay, by backward chaining. So criminal West is what you need to prove, right? So you are putting criminal West on the top, and then you are finding the rule with criminal West on the right side, and you are getting all these premises, right? American West, weapon Y, cells West, M1Z, etc. So you need to prove each of those. Okay, American West is true. You have proved here. It's already been proved, so there's no need to go further down. Weapon Y, you need to see what is the substitution that you can make. So if you make the substitution Y is M1, then weapon Y will give missile Y. Okay. So and if you take cells West M1Z, you can find what has this on the right side, and you need to prove these two things, and you have made these substitutions. Okay, so the missile M1, so M1 has already been put there, owns no M1, and then the next one here is hostile no, and you can do that by saying enemy no America. So you are moving down here, and all these are proved to be true because they are all facts in your knowledge base, right? So at this point you have proved the criminal West. Okay. So to prove criminal West, we have to prove the 4 conjuncts below it. These 4 conjuncts. Okay. Some of them are in the knowledge base and others require further backward chaining. And the binding has to be done. Okay. The appropriate substitution will have to be done. And whenever one sub-goal succeeds, for example, Y you are putting as M1, you are going to continue putting Y as M1 in all the other parts on the right side of it. Okay, next one is the resolution. Okay, so how do we take care of the resolution? So in first order resolution, what we do is we need to bring it in what is called the conjunctive normal form or the CNF form. So you have conjunction of clauses and each of the clauses is a disjunction, okay, of literals. So let's see what are the steps to convert to conjunctive normal form. So literals can contain variables which are assumed to be universally quantified. For example, suppose we have a sentence all X, American X and weapon Y and cells XYZ and hostile Z implies criminal X, okay. What we need to do is we need to use the, if you have something like A implies B, you have to get rid of this implication and you have to put this as not A or B. So that's what is done here, okay. So you are taking not A, so the left side here, not American X, and De Morgan's rule, all the and will be converted to or. So you'll get and American X, sorry, not American X, or not weapon Y, or not cells XYZ, or not hostile Z, or criminal X, that is and B part, okay. So that is how you are converting it to CNF, and we can see that this is in conjunctive normal form because you have only disjunction inside this sentence. So using this sentence here, let's see how we change it to conjunctive normal form. So we can see we have a sentence here which says everyone who loves all animals, okay, is loved by someone basically, okay. So that is your sentence. So the steps to convert to conjunctive normal form, the first step is to eliminate all the implications. So that is done by using what we did here, okay. A implies B is replaced by not A or B, okay. So here you have all X, so you are removing this implication, so you will get not of all Y, not animal Y or loves XY, and this you have another implication, so this is also replaced by this all X, and here you get or exists Y loves YX, okay. So this is how you have eliminated all these implications here, okay. So that is your first step which you are going to use. The second step is that the negation is moved inwards, okay. For example, if you have it outside the quantifiers, not all X P will become exists X not P, okay, and not exists X P will become for all X not P, okay. So if we have this sentence, this is the sentence we have, okay. So this will become for all X exists Y, animal Y, and because you have by De Morgan's law, this will become and not loves XY or exists Y loves YX. So this is your sentence as of now, and you need to standardize the variables. In other words, use different variables, okay. The same variable name cannot be used again, okay. So for example, this Y and this is XY, okay, and here this is different, so you have to say Z here, ZX, okay. So this will become the sentence after you have standardized it. Then you carry out scolemization. So scolemization is to remove the existential quantifier, okay. So what you are going to put here is animal f of x, okay, which means it's a function of x. So x is the person, okay, loves x, y. So function animal as a function of x you are putting, and here again you have exists z and you are putting that as g of z which is a function of x, basically. This should be x basically, okay. So f and g are the Coulomb functions which are used. Then next step, you are dropping the universal quantifier. So the universal quantifier which was outside, you remove it. So you get this sentence, and then distribute to and or. So what do you get? You use that law of distribution, right? We saw earlier, just like in algebra, etc. Distribution. How do you do that? You'll get animal f of x or loves gzx and loves x f of x or loves gzx. Okay, so this is what you get after distributing, and then this is one term and this is another term which is separated by the and. So this is in conjunctive normal forms. Okay. So once you get into a conjunctive normal form, you need to use the resolution principle. So resolution principle, like I said, you find two clauses which have one predicate which is in the positive form and in another one negative form, and then you can eliminate the complementary literals. So it basically you are eliminating complementary literals over here. So what you are doing is that if you have something like not P or Q and you have P or R, you are combining these two, okay, and you are eliminating not P and P and you are getting Q or R. So this is in a simple form where we look at the propositions, but you will also have, say, variables, or you will have elements over here. Okay, so you need to use those also in the case of predicate logic basically. Okay, so if you combine these two, okay, not loves uv and you have loves gx. Okay, so you are taking these two and you are trying to eliminate these two. You are going to get animal f of x or not kills g of x x. Okay. So that is the resolution, and you are getting a new clause basically. So we saw this earlier, so I just put it to show you how you are removing the complementary predicates here, and you are also carrying out the substitution over here. Okay. Okay, so let us take some examples. Okay, the first one is the missiles thing, right? So I have put all the statements here. Okay, so this is your complete knowledge base which we have, right? We can see that each of these sentences has only or. Okay, so there's no and. Okay, so it is in conjunctive normal form basically. Okay, and the goal is to find criminal west, so we take not criminal west, okay, and add it to this knowledge base, and what we do is we carry out resolution using this, and we need to come up with the nil predicate in the end. Okay, if we come up with the nil predicate, it means that criminal west is true. So how is this done? So we can see you can combine, okay, different. So this is a little more complicated than the previous example that we saw. So here we have, if we take the first one, okay, not American X or not weapon Y or not sells XYZ, etc. That is one of them we have taken, and you can take American West, right? So if you combine these two, then this American X and American West is going to be eliminated because of resolution, and X will be replaced by West in the rest of the sentence. So you are going to get not American West, okay, or not weapon Y, etc. Then this is combined with American West. So when you remove these two, you are going to get not weapon Y, etc. So you, I'll not go through the entire thing. You just keep carrying out resolution by using two sentences which have predicates which are where one you have the positive, there the negative of the same predicate, and you keep doing that and you will find that you are coming up with this nil predicate here, which shows that American West is true. Okay, so this is how the resolution actually works in this case. Okay, now let us look at another example. Okay, we have a problem like this. Everyone who loves all animals is loved by someone. Anyone who kills an animal is loved by no one. Jack loves all animals. Either Jack or Curiosity killed the cat, who is named Tuna. Did Curiosity kill the cat? Okay, so you have to replace this by the predicate logic. So everyone who loves all animals, all X, all Y, animal Y implies loves XY, which implies that there exists some Y such that loves YX. Okay. Second one, anyone who kills an animal is loved by no one. For all X, there exists Z, animal Z, and kills XZ implies for all Y not loves YX. Okay, so this way you can replace all of them by the predicate logic sentences. So you will come up with these. Then we need to convert each sentence to conjunctive normal form. So the first sentence, okay, you need to eliminate the implication signs over here, okay, and the second one also you have to remove the implication signs. All the rules you need to replace the implication signs and bring it down to the smallest form. So once you do that, you are getting these sentences, okay. A1 and A2 is from the first sentence A. Animal f of x and loves g of x of x. So what you have done basically is remove the implication and also carried out scolomization, okay. And then B. So B, you are going to get this. So you can actually convert these. So this is going to be, if we take the second, say the third sentence, okay. So you have something like all X animal implies loves Jack X. We need to remove the implication. So we can say not animal X or loves Jack X. Okay, so this way you need to work on all these sentences. This also will be not cat X or animal X. Okay, so we can get all these sentences and then carry out the resolution proof for Curiosity killed the cat. Okay, kills Curiosity to Tuna. Okay, so this is your what you need to prove. So you take the negation of that. Okay, so this is how you can go through this and you will come up with a nil here, which shows that Curiosity killed the cat is actually true. Okay. So in English, if we look at this, right, it will give you an idea of why we are trying to take the negation of not kills Curiosity Tuna. Suppose Curiosity did not kill Tuna, we know that either Jack or Curiosity did. Thus Jack must have. Now Tuna is a cat and cats are animals. So Tuna is an animal. Because anyone who kills an animal is loved by no one, we know that no one loves Jack On the other hand, Jack loves all animals, so someone loves him. So we have a contradiction. Therefore, curiosity killed the cat, right? So that's what we are trying to prove by taking the negation of this and adding it to this. Okay, so let us look at strategies for resolution. So we can see here that this looks quite complicated, right? If your knowledge base is very big, how do we go about finding which are the sentences you are going to combine for resolution, right? So we have combined these two, then these two have been combined, and whatever you get has been combined with something else, etc., right? So this is fairly complicated. So how do we find out what is the ones we need to combine, right? And what is the order in which we do this, okay? So let us look at some strategies for doing this. First strategy is what is called the unit preference. So what is this unit preference? You try to see sentences with a single clause, okay? So it is something like this. If you have not P, and you have P or R, and you're combining these together, you are going to get the single R. Okay, so this works out to be much shorter if you take some single ones like this. Okay, or if you have something like P or Q or R, so you will get P, Q or R, right? So you are coming up with a smaller clause by taking unit sentences. Okay, so if we take unit sentences, it helps over here. So unit resolution can be used, okay, as one of the strategies, not necessarily the only strategy that you are using. The second strategy that we use is what is called the set of support. Okay, so you keep a few sentences and you say that whatever you are going to combine together, one of them will be from the set of support. Okay, so of course it's necessary to find out what goes into the set of support. Okay. For example, you can insist that every resolution step involves at least one element of a special set of clauses. Okay. Now, how do we find that special set of clauses? And if the set of support is small as compared to the entire knowledge base, it may be much faster, right? So if you don't choose the right set of support, you may the algorithm may be complete and may not be complete. You may not get the result that you are looking for. So it is necessary to see that you find the right set of support. For example, one can use the negated query as the set of support. Okay, so the query which is there and you are negating it, you can say that has to be there in every resolution that you are using. Okay. So that is the second strategy. Third one is input resolution. It means that every resolution combines one of the input sentences. So you have the set of input sentences with which you are starting, and at least one of the sentences in your resolution will contain one of the input sentences. Then the next one is what is called subsumption. So what you do here is look at your knowledge base, and if you find that there is anything redundant in your knowledge base, you can remove those things. And once you remove it, you keep the knowledge base as small as possible. Okay. For example, if you have say P of X is in your knowledge base, then there is no point in adding P of A, because P of A is also there in P of X basically. And also there is no point in saying P of A or Q of B, right. So subsumption actually keeps the knowledge base small. So these are all some of the resolution strategies which can be basically used, right. Okay, so here is one example which is more like a homework problem. So here Marcus is a man, Marcus is a Pompeian, Marcus was born in year 40, all men are mortal, all Pompeians died in the year 79. Volcano erupted in 79. If a person is mortal, born in T1, and if T2 minus T1 is greater than 150, then he is dead in T2. Now it's 2025, you want to change this. If a person is alive in T, then he is not dead at time T, etc. So what we need to prove that is that Marcus is not alive now. So in other words, Marcus is mortal, and if he is mortal, he is dead now. That's what we need to prove over here. So basically, you can combine, you can take each of these sentences and you can convert it into predicate logic, and then you need to prove Marcus is not alive now. So you can take alive Marcus now and add it into your knowledge base and try to show that Marcus is not alive now. Okay. So this I am just giving as an example which can be tried out by anyone who wants to do it. So basically just to take one or two of these, we can say, for example, so you could have something which says man Marcus. Marcus is a Pompeian. Marcus, born Marcus 40, all men, all X, man X implies mortal X. This one, all Pompeians died in the all X, Pompeian X implies died X in the year 79. Volcano in the year 79, right? Or we could say erupted volcano in the year 79, okay, etc. So you can continue doing in the same way and then convert it into conjunctive normal form, and finally add not so we will say alive Marcus now. Okay, and we can put now equal to 2025 or 2028 or whatever, 2008, etc. Right? So please try this problem. So we'll stop here in this session.